Greetings. In this video, we'll be talking about nomenclature of alkynes. That is just a fancy word for naming. So we're going to learn how to name alkynes. I think you'll see that it's actually really simple. It's essentially the same thing as alkenes, except you use the YNE ending instead of the ENE ending. And it's actually simpler because there's no such thing as cis or trans. There's a little complication in that we have to worry about what happens when you have both an alkene and an alkyne in the same molecule. And we'll see that from now on, that's going to just get more and more complicated because we're going to get more and more functional groups, any of which could occur in any particular molecule. But for now, we're going to learn about alkynes, and then we're going to learn how to handle it if you have both an alkene and an alkyne in the same molecule. So before you view the rest of the video, please study and read section 7.2, pages 257 and 258. Here are some common names. As with almost all families of compounds that we're going to come across, there are some common names, sometimes even a system called the common system for naming. And then there is what's called the IUPAC system. We saw that with the alkanes. And so let's start with common names of alkynes. Again, it's actually very simple. There's really one you have to memorize, and that is the simplest alkyne. That is a 2-carbon alkyne with hydrogens on both ends. Is called acetylene. Now that in itself is weird because it has an ENE ending, which makes it seem like it's an alkene. And it has a YL in there, which is actually part of the name of the base molecule, not a substituent on it. And again, that's a little bit weird. And one other thing, the ACET group, we will see very shortly that generally means a methyl group with a C double bond O. Clearly, that's not what it means in this case. So for all sorts of reasons, acetylene is just a very strange name for this compound. Nevertheless, that's the common name for it, and you've probably heard of acetylene in, for example, acetylene torches. It's used as a fuel, burns very hotly in acetylene torches, so that's what acetylene is. The rest of the common names are based upon acetylene. So basically, anytime you have a triple bond, with some other groups attached, you can say whatever the group is that's attached, and then say the word acetylene. So in this case, it's an isopropyl group attached to a 2-carbon triple bond, and so it's called isopropyl acetylene. This one, you have both a methyl group on one end and an ethyl group on the other end of the 2-carbon triple bonded bond. So it's an ethyl and a methyl on acetylene, so it's called ethyl-methyl acetylene. This one has an N-propyl group on one end of the triple bond and another N-propyl group on the other end of the triple bond, and so it's called di-N-propyl acetylene. So I think you can see the common system pretty simple. You say the word acetylene, and then in front of it, you put whatever group or groups are attached to the acetylene molecule or to the triple bond. Now, let's talk about the IUPAC system. As we saw with alkanes and alkenes, it's basically the same system. You're going to find the longest chain. You're going to number it from one end or the other. You're going to put in a root that indicates how many carbons there are. For example, meth, F, prop, bute, pent, hex, and so on. And you're going to put an ending that indicates what the functional group is. In this case, we're going to put the ending YNE for alkynes. We saw for alkenes it was ENE, and for alkanes it was ANE. And so, again, that makes perfect sense. One thing, as I mentioned, that makes this easier than naming alkenes is that there's no cis-trans isomers. So you don't have to put cis-trans, you don't have to put EZ in front of the name ever. Unless there also happens to be an alkene in the molecule. But if there's just triple bonds, then no cis or trans. And one other thing that's interesting is we generally don't talk about cyclic alkynes. We did learn quite a bit about naming cyclic alkenes. With alkynes, it's really the same system if you did have. But the problem is because triple bonds are straight across, they can't bend essentially. So it's really hard to make a ring with a triple bond in it. In fact, you really have to get to 8 carbons, and even then it's very unstable. So 9 carbons is about the smallest ring that you find with a triple bond in it, and that would just be called cyclo-no-9. But we're not going to even worry about rings with alkynes because they're just so rare. So, some examples of IUPAC system. Let me point out, the longest chain includes both carbons of the triple bond. Just as we saw with alkenes, the longest chain has to include both carbons of the double bond. And so you base your name on how many carbons are in that longest chain. Then you decide which end you're going to number from. In this case, it's a little tricky because if you number from this end, you get to the triple bond at carbon number 4. If you number from this end, you get to the triple bond at carbon number 4. So then how do you decide? Well, obviously, based on other substituents, so this one's closer to this end. And other than that, it's just like alkenes. This one, here's the longest chain. It has a substituent on that carbon right there. This one here's the longest chain, has 2 substituents on that carbon right there. So with those hints, stop the video and write down the IUPAC name for each of these compounds, and while you're at it, go ahead and give the common names as well. Now we're going to go to the next slide. So the common name for this compound is isobutyl, because this is an isobutyl group, secbutyl, because this is a secbutyl group, acetylene, because that is an acetylene right in the middle. So if you didn't remember that this is an isobutyl group, remember it. These 4 different butyl groups that we've talked about, you'll see them over and over and over again. So there's N-butyl. Most people don't have too much trouble with that. There's T-butyl, which we'll see here in just a minute. And then the ones that people have trouble with are isobutyl and secbutyl. So let me just take a minute and remind you, an isobutyl group has 3 in a row with a methyl on the second carbon of the 3. A secbutyl has 3 in a row with the methyl group on the first carbon attached. One other thing, isobutyl has this iso group in it, and by iso I mean a carbon with 2 methyls. That makes it an iso group. Okay, what about the IUPAC name? Well, as I said, it's really straight across here for a total of 8 carbons, and so it's going to be octyne because of the triple bond. The triple bond starts at carbon number 4, whether you count from this end, 1, 2, 3, 4, or whether you count from this end, 1, 2, 3, 4. So it's going to be 4-octyne, but we need to number it because we need to indicate where those methyls are. So do we number from this end? Yes, because we get to the first branch point at carbon number 2. If we measured from this end, 1, 2, 3, we wouldn't get to the first branch point until carbon 3. So we number from this end, and so the methyl groups are at carbons number 2, 3, 4, and 6. 2 and 6, so 2,6-dimethyl 4-octyne. This one, the common name, again we use acetylene with whatever this group is attached, and that's an N-butyl group, and a cyclohexyl group. Don't forget you can have cyclic groups. You just put a cyclo in front of it, so it's a cyclohexyl group, and so this is N-butyl cyclohexyl acetylene. That's the common name. The IUPAC name uses this as the longest chain. Obviously that's carbon number 1 because it's the triple bond is closer to this end than it is to this end, so that's carbon number 1. And carbon number 1 happens to have a cyclohexyl group on it. So it's 1 cyclohexyl, 1 hexyne. Don't forget to put that 1 in there because that indicates that the triple bond starts at carbon number 1 and not somewhere else in the chain. And then this molecule, its longest chain is 1, 2, 3, 4, 4-carbon chain. Triple bond starts right here, so this is carbon number 1, 2, 3, and we have 2 more methyl groups at carbon number 3, so it's 3,3-dimethyl 1-butene. Triple bond starts at carbon number 1. Now, if there are 2 or more triple bonds, as is very possible, just as we saw with alkenes, you can have dienes and trienes. So is true with triple bonds. You could have dienes and trienes and so on. So what do you do in a case like this? Well, again, we're going to number from the end as closest to the first of the triple bonds. If they're equidistant from the 2 ends, then of course we'd have to use whichever end is closest to the first branch point, and so on. In any case, go ahead and stop the video and just go ahead and give me a name for that compound. Don't forget it's a diene because there's 2 triple bonds in it. Next slide. If we count the carbons, there's 1 there, 1 there, 1 there, so that's 3. 1 there is 4, 5, 1 there is 6, 7, 8, 9, 10 carbons, so deca. Diene, because there are 2 triple bonds, and notice the numbers, number 1, 2, 3, so triple bond starting at carbon number 3, 4, 5, 6, triple bond starting at carbon number 6, so that's 3, 6 decadiene. One more thing, what if we have both a double bond and a triple bond in the molecule? What the rule says is that if there's both a triple bond and a double bond, the double bond takes preference in numbering. Then the ending, because it's got both an alkene and an alkyne, has to have 2 endings. It has an ene ending and an ine ending. So the ending is in the order of precedence. So ene comes before ine because, as I said, the double bond takes precedence. So it's going to be, the ending is going to be ene, ine. And then the position of the double bond in the name is given in front of the chain name. And then the position of the triple bond is given before the ending, ine. So, given those rules, let's go ahead and name this molecule. Why don't you try it, stop the video, and see what you come up with for your name, and we'll move on to the next slide now. Okay, so 6,9-dimethyl 4-decene 7-ine. So how many carbons altogether in the longest chain? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 carbons, dec, and because it's both an alkene and an alkyne, it's decene-ine. Numbering is from which end? Well, this end is closest to the triple bond, but this end is closest to the double bond. And as I said, the double bond takes precedence. So 1, 2, 3, 4. So the double bond starts at carbon number 4, so it's 4-decene. And then, that's 5, 6, 7. The triple bond starts at carbon number 7. So we put the 7-ine in front of the ine ending. We can't put it in front of the whole thing because then it would be 4-7-decene-ine. We wouldn't know which one was the 4 and which one was the 7. So we put the 7 in front of the ending. We put the first group that's listed in terms of the endings, we put its number in front, just like we have before. And then, of course, in this case, we also have a methyl group of carbon number 6 and a methyl group of carbon number 9. So it's 6,9-dimethyl, 4-decene, 7-ine. And that's the end of this video. Thank you.